So this question is related to get level minimization. And these are the questions of the university questions they have asked multiple times. First question is realize AND gate using NAND gates. So the simple representation of the AND gate is like this. This one we have to realize with the help of NAND gates. So now you know the symbol of the NAND gates. Okay. So AND gate followed by the bubble is the NAND gate. Now to compensate this bubble, we have to use the inverter. Okay. So that again, this inverter, again we can realize with the help of NAND gate itself. So finally, now this inverter as the NAND gate will be done like this. So here if input is A and B, so finally what will be the output here? That will be AB dash. And it is inverter, so again we are going to get the AB. Second one is the prime implicant. So that prime implicant we are going to obtain by combining the maximum adjacent mean terms. Okay, maximum adjacent mean terms we are going to combine and we'll obtain the product terms. That is called as the prime implicants. Apart from this prime implicants, we have another third thing is sometimes maybe they will ask you what is the essential prime implicants. So essential prime implicant is what? How it is different from the prime implicant? So essential prime implicant should have at least one mean term. Okay, at least one mean term that cannot be shared in any other combination. That is called as the essential prime implicant. But in case of simple prime implicants, those mean terms can be shared with other combinations. Okay, that is the difference. Next is so here we can have either quotient prime implicants or essential prime implicant also. Now you are seeing that here they are asking realize OR gate using NOR gates. So such type of the one question you are going to get. So OR gate symbol. Okay, this is the simple OR gate. So here if you give the input A and B, so the output is what? A plus B. So these things you have to realize with NOR gate. So what is the NOR gate symbol? OR gate followed by the bubble is the NOR gate. So again here, this bubble will be compensated by the inverters. So that inverter again, we are going to design with the help of NOR gate itself. Okay. So now here again, output should be A plus B. So here we have A plus B dash. And here inverter again, A plus B. Since complement of complement, we'll get the same numbers. So like this, you can have another objective question also. Okay, so that you need to practice. Next, we have long question. So one K-map question is compulsory. It's sure that one K-map question will come. So 90% chance you will get with the don't care condition. Okay. So don't care condition, what is the don't care condition? We are not sure about this, that what will be the value of that. It can be 1 or it can be 0. So here maximum mean term is the 15. Okay. So that means we have to the power 4, that is the 16. Okay. So here how many variables are required? 16 means you are able to represent 16 mean terms 0 to 15. So here 4 variables. Sometimes in the function itself, variables will be written like A, B, C, D or W, X, Y, Z. Here it is not given. By seeing the maximum value of the mean term, you have to recognize, you have to decide how many variables are there. So how many variables? That to the power n will be going to give us the number of square boxes. So here variables are 4. So to the power 4 is the 16. So 16 square boxes required here. Okay. A, B and C, D we are considering here as the variables, literals. So 0, 0, 0, 1, 1, 1, 1, 0. Here you know that at a time only one literal should change. That's why after 0, 1 we don't have 1, 0. We have 1, 1. Similarly here in the upper side also after 0, 1 we have 1, 0, 1, 1, not 1, 0. Okay. So at a time only one literal will change. And somebody if want to write this one, you can write this one C dash D dash. You can write here C dash D, and this is the CD, and this is the C D dash. Similarly, here we can write A dash B dash. This is the A dash B. This is the AB, and this one is the AB dash. Okay. And these mean terms inside 0, 1, 2, 3 is written on the basis of combination of this what horizontal box and vertical is going to miss. So 4 0 is equal to 0. Now here 0 0 0 1 equal to 1. Like this we are able to write here. So first we'll put the mean term which is without don't care that we are going to write. So here given is the 0 is there, 1, next we have 2, next we have 5, next we have another is the 9, next we have 12, next is the 13, and next is the 15. Apart from this, don't care conditions are there. So that don't care condition we are going to write. So 3 is the another, next is the 4, next what we have? 6, next 8, and last one is what here? 11. Okay. So now in this we have to make the combination. So here clearly if you see that first two columns, okay, in this we are able to get the, okay, so by including two don't care, we are able to make one octet here. So for this octet, row wise, nothing is common. Column wise, what is the common here? C dash. Okay, so we'll have here C dash. Now you see that again first row. So in the first row again, you'll have that combination we are able to obtain here. So all four adjacent mean terms. So that is going to give us one quad here. So for this row wise, what is common? A dash, B dash. And column wise, anything will get common? No. Okay. And now still one mean term is left, that is the 15th. Okay. So we'll make here one pair. If you are interested, you can make the pair with don't care also, but unnecessary why to include the don't care. So for this, row wise common is AB and column wise common is what here? D. Okay. So that's we are writing the D. So it is ABD. So finally this F, what we have? C dash plus A dash B dash, okay, plus ABD. Now what they're asking the next second part is what here? First need to simplify by using K-map. Then you have to draw the logic diagram by using AOI. AOI is what? AND or invert. So that logic diagram we have to utilize here. Okay. Here they are not asking that you go for the NOR implementation or NAND implementation. Okay. So simply you can draw the logic diagram for this. Okay. Everybody will be able to draw. So here again, if you want means you can have like A, B is with complement, D is without complement, C is complement. So we have very simple part. We want means we can draw here. So for this one AND gate, for this again one AND gate, and here sum means one OR, again OR gate. So here single OR gate we can utilize and two AND gate is required here. So one AND gate will take here. Again, another AND gate is required. Okay. And one OR gate we are going to use here. So now in the first level, first AND gate input is what here? A dash. So that will be complemented. This is A. So here what will get? A dash. Another is what? B dash. So we can go like this. So this is the B, this will be the B dash. Okay. So for the better, you can use the scale here. So proper input should be given in the proper way. So from this AND gate, what is the output? A dash, B dash. Second AND gate, what are the inputs? A, B, D. So already we have A here. So same A will take as the input by using the wire. Again, we have B. And third input is what here? D. Okay. So that D we can give here as the input. Try to manage the space. So this is the D. And output of this is what? A, B, D. And next is the C dash. So this is, we'll take here C. This is going to be C dash. So C, C dash. So this C dash is going to be the input directly to the OR gate. And this is the another and one more. So finally all are combined here. And this is your final function. Like this, we are able to implement also by using AOI logic. So the K-map, one question is compulsory, that is going to come. Now, apart from the K-map, here what we have? Quine-McClusky method. So this method is also called as the tabulation method, okay? So one question also from here, K-map. So sometimes you can manage with tabulation without tabulation method, but if question is in the different way, with another question, that question may be easy for you, then you have to attend the tabulation method. So generally tabulation method we use for the higher values. When we have more variables, then it is going to help us. So here if you see that we have only 4 variables are there, then since the maximum min terms is what here? 15. So now for the easy understanding, you can write the min terms here. Okay, and that min terms in the form of binary. So here 4 variables are there. So first, the smallest min term is the, so including don't care also we are going to write. Okay, that's not a problem. So now here 0 means it will be represented with the 40. Next we have 1. So 0, 0, 0, 1. Next what we have? 2. So 2 how will write? 0, 0, 1, 0. Again 3 we have. So 3, 0, 0, 1, 1. Next what we have? 5. So 5 means 0, 1, 0, 1. Apart from 5, next what we have? 7. 7 how will write? 0, 1, 1, 1. Next is 9. So 9 how will write? 1, 0, 1, 1. No, 1, 0, 0, 1. Okay, 8 plus 1. 9. Next what we have? 11. So 11 how will write? 1, 0, 1, 1. And last one is the 15. Okay, so 15 means all are 1. So total how many terms are given? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have written 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so now all 9 we have taken. So what is the logic here? Now we have to make the group of these mean terms on the basis of number of ones. Okay, so first 0 will be only one mean term which doesn't have 1. So this means here number of ones is 0. So that will come in the one group separate. So first table, okay, here we are going to rearrange. So this is we call as the group, and here we have mean terms. And here again we have variables. So what are the variables? A, B, C, D. So here we should be careful when we are arranging the numbers here. Okay. So first mean term is what here? 0. That having all as the 0. So this will be kept as the one group. So that we can give the group number 0. Another will have number on the basis of number of ones. So this one we have done. So by pencil you can mark. Okay, this one you have taken. Next, what we have? 1. So 0, 0, 0, 1. This one also we have taken. 2 also having number of ones as the 1 only. So we'll write 2. Then we have 0, 0, 1, 0. Okay. Apart from this, none of having a number of ones as the 2. So this will keep as the one group. Next, we'll have where we have number of ones is 3. So that is the mean term is 3. Also 0, 0, 1, 1. Next, which one we have? So 3 we have taken. Next is the 5 itself. So 5 number of ones 0, 1, 0, 1. So 2. Next what we have? 9. So 9, 1, 0, 0, 1. Okay. Apart from this, anyone having that number of ones as 2? No. So next we'll have 7. Okay. 7 having number of ones is how many? 3. So we'll have 0, 1, 1, 1. So 7 we have taken. Next what we have? 11. Okay. So 11. 1, 0, 1, 1. So this is the next group. And last one is the 15. Since here number of ones are how many? 4. Okay. So this is the another group. Now we are going to compare consecutive groups, one group with another groups. Okay. So now in this group pairing will takes place from one group to another group. So for that another table is required here. Table 2. So in that we are going to compare group 0 to group 1. So here which literals are different. For that we are going to write the dash. So we'll have again table for that here group. This one is the pair. And again we have variables, that is the literals A, B, C, D. Okay. So sometimes maybe it takes more time as well as place also. So you have to manage according to that. So pairing will be what here? 0 and 1. So which literal is changing? D is changing. So 0, 0, dash. Next we have 0 and 2. So which one is changing? C is changing. So 0, 0, dash 0. So this is the one group, one pair. Next we have to take the another one. So now we are going to do 1 with 2. So if we'll check here, we'll have 1, 3. So 1, 3, which one is changing? C is changing. So we have 0, 0, dash 1. Next, what we have? So again, if you see that 1, 5 is also possible. Yes. Yes or no? So that 1, 5 also, if it is possible, we need to write. Check it. So 1, 5. So 1, 5. So 1, 5 pair, which bit is changing? B is changing. So 0, dash 0, 1. Then what about 9? Yes, 1, 9. Which is changing? A is changing. So dash 0, 0, 1. Next, we'll check with 2 and 3. 2 and 3 is also possible. So if we'll have sometimes same pair means we'll write only one time. Generally in pair it will not occur. In octet we'll get like that. So 2 and 3 D is changing, right? So 0, 0, 1 dash. Next 2 and 5 is possible. No, 2 bits are changing. 2 and 9, that is also not possible. Okay. So this is the second group, that group number We have started with 0, so 1. So next group we have that we are going to 2 and 3. So in that, now compare 3 with 7. Yes, that pair is possible. So which one is changing? B is changing. So 0 dash 1 1. 3 11. Yes, 3 11 is also possible. Which bit is changing? A is changing. So dash 0 1 1. Here you have to compare. Like this is 3. This is the 11. You have to compare. So which bit is changing? Okay. So first bit A was changing. So where it is changing? Dash. So now we'll take the 5 with 7. 5, 7. That is also possible. So 5, 7, which one is changing? This is the 5. This is the 7. Which one is changing? C. So 0, 1 underscore or dash 1. Okay. So now 5, 7 we have completed. Next, what we have? 5, 11 is possible? No. So now you check with 9, 7. 9, 7 is possible? No. 2 bits, 3 bits are changing. Or whether 9, 11? Yes. 9, 11 is possible. So this is your 9, 11 here. Which bit is changing? C is changing. So 1, 0, dash 1. So this is the one group. So this is the table 2 that gave the pair. Okay. Next we'll have another table is required now. Table 3. So this video will be lengthy, but it's very informative. So similar question, maybe same question also you are going to get, or only mean terms will be different. Group. So now what we'll get here? Quad. And again literals A, B, C, D. So now in this, you have to check that if underscore or dash is at the same place, okay, then we'll look for the change of the another bits. So here on the basis of that, if you see that we have 0, 1, 2, 3. Okay. 0, 1. This is the 0, 1. This is the 2, 3. Okay. This one having only one bit is changing now. That is the C. So what we'll write here? 0, 0, dash, dash. Okay. Apart from this, next what we have? This is group 0. So next we have another combinations that we have 1, 3, 9, 11. So for this, you see that which one is changing. On the basis of that, we have dash 0, dash 1. Next, we have again 1, 3, 5, 7. If you see that same combination we are getting, then we'll write only one time. 0, dash, dash 1. So first we have to check the underscore or dash should be in the same place. Okay. Next one more is possible. That is the 3, 7, 11, 15. So here again, dash, dash or underscore 1. Now further, any other possibilities are there? No. So now here, if you see that further possibilities are not there, then again we have to look that whether all mean terms are covered or not here. If mean terms are not covered, then for the particular mean terms, we have to look back to the previous table. Okay. So here if you see that 0 is there, 1, 2, 3 is also there, 5, 7, 9 is also there, 11, 15, all are there. So don't care is also available. Suppose in case don't care is not in the last table, then no need to look in the previous table. We can ignore that also. So last one will be what here? We have prime implicants table. Okay, prime implicants. So this will be the table number 4. So in the prime implicants, what you are writing? So like here, A with 0 means A dash, B 0 means B dash, C, D no need to write here. Okay. And that corresponding, what are the Mean terms are given, that mean terms we need to write. So mean terms are here 0, 1, 2, 3, 5, 7, 9, 11, 15. Okay. So now here we have to look for the values. So first one, okay, from here what we'll write? What we'll have? A dash, B dash. So this cover, what are the mean terms? What are the mean terms going to cover? 0, 1, 2, 3. Next we have second one. So for this what we'll write? What we can write for this? B dash D. So this cover, what are the mean terms? 1, 3, 5, 7. Like this you can check if any mean term is missing. So for the third one, what we have? We have A dash and D. This covers the mean terms 1, 3, 5, 7. Last one is what we have? That is the CD. CD. That covers the mean term 3, 7, 11, 15. So here first one for the second B dash D, maybe we have missed something. 1, 3, 5, 1, 3. Here a small correction to parallel error. We have written wrongly. So this is what are things it's covering. So 1, 3. Okay, see this one. 1, 3, 9, 11. 1, 3, 9, 11. Okay. And A dash D is the correct 1, 3, 1, 3, 5, 7. So from here, what we are seeing that all mean terms are covered at least one time. Okay. So finally, so no need to go back to the previous table. So finally now F is equal to A dash B dash plus B dash D, okay, plus A dash D plus CD. Okay. So like this, you can write, somebody is writing bar in place of dash, you can write the bar also. So this is also sure questions. Okay. So like and share with your friends as well as subscribe also. Okay. So that our community is going to increase. Okay. So next we'll see that what is the next question. So we have again another K-map is there. This is the another year questions. Okay. So you are seeing that K-map is the one of the sure question that is going to come. So now finally in this already we have seen the previously also one K-map. So the similar situation is here so that we can do quickly this one about this. So finally the values, what are the values are given that we have to write in this. So for this, for the first we'll go for the first part. So here again, mean terms is given and along with don't care. So four variables are there. So here in the function itself, variables are given A, B, C, D. Okay. So no need to worry. We can go with this. So finally, here, what are the mean terms are given? So in this case, see that this is the small m. So small m represent what? Sum of product. And this pi and capital M represent the max terms. Okay. So max term means will be product of the sum. So that you know that max term is the complement of the mean terms. That concept also we can use. Okay. So first we'll see this one. So here what are the values are given for that without don't care what are things are given. 0, 1, again we have 2, 3, 4, 5. Okay. Next, so many don't cares are here. So don't care first one is what here? 10. 10, 11, 12, 13, 14. Next we have 15. Okay. So on the basis of that, we have to make the combinations. So here you are seeing that it's looking that it has column wise. So this common is what here? A dash, B dash. So one quad we have formed. Another two midterms is left. So this midterm also we can make another pair quad. So for row wise, what is common here? A dash, column wise common is what? C dash. Okay. So finally, this one easily we can write F equal to A dash, B dash plus A dash, C dash. Okay. So here if you see that you have two AND gate is required and one OR gate. And here if you want that we have common also A dash. So then we'll get inside the bracket B dash plus C dash. Now for this one, for the second one, okay, this is the first one. For the second one here, what are things we have? Again, so here we are going to take by the help of what we will say, complement of the midterms is that concept we are going to use, okay? Complement of the midterm is the max terms. So first you see that what we have 0, 1 is given, 2 is given, 3 is given, next 6 is given, next what we have 8 is given, next 9 is given, next what we have 10, 11, 14. Okay, so here we'll take the complements. So which values are not given, that we are writing as the 0, that is the complements. So for this itself you can make the combination for the complements. So this one if you see that we'll have one quad here. So for this quad, what is the row wise common? Okay. So this one again here you need to write A, B, C, D, all these things. Okay. Then on the basis of that, here what is the common? So here A, B, C, D is we should not write what is given here. Already given WX. So this is the WX, YZ. So here row wise, what is the common? X is common and column wise Y dash is common. So this is the X, Y dash. And one more quad is this for this one. Okay. So what is the value? Again here row wise common is X and column wise common is the Z. So finally this will be F dash equal to XY dash plus XZ. Now in this, we are going to take the complement of this function. So complement of complement will be the same. And here we have X, Y dash plus XZ overall complements. So now we'll apply the De Morgan's theorem. So X, Y dash, dash, this plus will change into dot. So X, Z dash. Again, apply the De Morgan's theorem. So we have X dash plus Y. Okay. And here dot is already there. This is the X dash plus Z dash. So this is the product of sum. Okay. Like this, we are able to solve the K-map for this. So this is also important question. So you have to see in the hurry and worry, you should not do the mistakes. Here what we have, capital M means max term, a small m means mean terms. So complement of the mean term is what? Max terms. On the basis of that, we are solving here. And later we are applying here De Morgan's theorem. I hope this will be useful for you. Okay. So this is going to save your time also. This K-map you can do in the less time. Okay. Another you have implement two input XNOR gate using the NAND gate only. So now in this what we have to do? First, we have to XOR gate. So XNOR expression is what? AB plus A dash B dash. Or in the symbolic, we are writing like this. Okay. So here two AND gate is required. Normally, if you are going to represent AB, another AND gate here. Okay. So that one Again, you are going to take with inverter. We can use A dash, B dash, and finally it is given to the OR gate. Now here what that's telling us, implement by using NAND gates. So for that, what is the logic? AND gate will be changed into the NAND gates. So here we are going to apply the bubbles. Again, this AND gate will change into the NAND gates. Okay. And here we are going to apply the bubbles before the OR gates. Okay. So here we have only two stages. So usually you can do A, B, this is the A dash, B dash. To compensate these bubbles, here we are going to apply the inverters. Okay. So this inverter, both inverters are being cancelled, complement of complement. Okay. So that's easy here. And finally, this will be done like this. We have AND gate, that is the now NAND gates. Again, another NAND gates. And this A, B, you don't want to write A and B multiple times. Then here you have to apply the inverter, and that inverter you have to write in terms of NAND gates. So that things you have to take care, otherwise you can write like this also. And finally again, this is the NAND gate and Y. So if you want means you can verify that output here stage by stage, that will be better. Like here what we have, A, B dash. Here what we'll get, A dash, B dash, dash. Again, similarly verify here. You have to see that are you getting AB plus A dash, B dash or not. If you are getting the same expression, then it is verified. Okay. Thank you. Hope it will be useful. Okay. And practice more and share with your friends also, as well as like, subscribes. Okay. Thank you. Thank you.